In this lecture, we're just going to focus on looking at the specific formulas for calculating the surface area, the area on the outside of various solid figures. And we're really going to leave looking at applications of those formulas to a later lecture, because it can kind of come at this from the perspective of people who may ultimately be teaching this material. It's nice to kind of know the background of some of these formulas, not only just in general, but also because it can sometimes point you towards activities that you can do when you're teaching this in a classroom. So we can start off looking at prisms. And what we're looking for here is what's called the surface area. That is the total area on the outside of a figure. And with prisms, the sides are always going to be parallelograms, and the bases are going to be some kind of polygon. So ultimately, we can always do this just brute force, find the area of each individual face, add them all up, and you get the answer. And with a general a general prism, especially one that's slanted, that's pretty much the best we can do. Now, there are a couple of special cases. For example, a right prism, in this case, one that's made from bases that are rectangles, we get what we think of as a box, right, or a rectangular solid. In this case, we actually can do a little better. There are two faces like this one, right? This front face and the back face. The area of those two pieces are the same. It's the length times the height, and there's two of them. Right now, if you look at the bottom, this face and this face, the area of those two is the length times the width. And again, there's two of them. Right? And finally, if we look at these sides, the two remaining faces, this one and this one, those areas are W times H. And again, there's two of them. So there's our formula, right? For the total area of a prism. Now, another formula that we'll sometimes talk about is what's called the lateral area. And that's just the area on the sides, not including the two bases. Right? So looking at, again, this figure here, that excludes the length times width one. So it's going to take those out, and the lateral area would be just 2 length times the height plus 2 width times the height. And over here, in the special case where we've got a cube, in this case, all 6 faces are the same. The area of each individual face is s squared, and there's 6 of them, so the total area will be just 6s squared. So suppose we're looking at a cylinder. What would be, well, let's start with the lateral area. So what would be the lateral area of this figure? Well, here's what I want you to do. Right? I want you to use your imagination. And I want you to imagine cutting down the side here, right? And then peeling the sides away and laying it flat. If you do that, and again, this is something you could actually do in a classroom setting, right? If you do that, what you're going to get is a rectangle. And we know what the area of a rectangle is. It's the base times the height. Well, the height of the rectangle is going to be h, and the length is going to be this piece here. Well, that's the circumference of the circle, right? We have a formula for the circumference of a circle. It's 2 pi r. So the lateral area is going to be the length, which is 2 pi r, times the height, which is just h. All right, now we want to go for the total area. Then we have to add in the two bases. Well, the two bases are just circles. The area of a circle is pi r squared, and we've got 2 of them. So the total area would be 2 pi r h plus pi r squared. So this leaves us with a sphere, and I know I've kind of skipped over pyramids and cones. There are formulas for the area of those shapes. They're kind of exotic. They're a little lengthy. They've got some square roots and some weird fractions and such in them. So it's not something that I think you're going to be teaching on a regular basis, even up into the secondary school, middle school level. So we're going to go ahead and jump up to spheres. And the formula for the area of a sphere, it is what it is, and there's really not an easy way I'm aware of outside of calculus to really get to what this is in terms of deriving it. So this one, you're just going to have to take my word for it. The area of a sphere is 4 pi r squared. Okay, so first I've summarized everything we've talked about here, right? Total surface area and lateral surface area. So you've got all those formulas in one place if you're writing them down. And I know that there's a lot. There are a lot. It's building up. Or there are a lot of formulas going on here. And we're going to add even more in the next section when we talk about volume. So this is the point where you really it's a good idea to start talking about study skills with students. What I like to do when you've got a whole bunch of stuff to memorize like this is go to index cards. Right? You get out index cards, and on the front of each card, you put the formula and you list what each variable represents. Maybe you put a little diagram. And on the back, you put an example of how the formula is used. And then you lay all those out in front of you. You've got them there as a quick reference. And the more practice you do, the more you use them, the more you're going to internalize that information, and the less and less you're going to need the cards. Okay, so like I said, in the next lecture, sorry, more formulas. We're going to really kind of go through this same treatment again, only this time talking about the volume of solids.